Today, we're going to do the protons, neutrons, and electrons, and then the average atomic mass for those two worksheets. So download them, and if you have a printer, go ahead and print them out. But we're gonna, remember yesterday we talked about the periodic table? We're pretty much going to be using the periodic table for the rest of the semester. So we're gonna need, you're gonna need the periodic table to reference it. So if you don't have one printed, I would suggest at some point printing one. If you have a book, that's helpful because you can always just use the one in the book. And if you don't have a book, then just always have one pulled up or have it bookmarked in your computer so you can easily access it. And like I said, I have the one on Brightspace, so you guys can use that one as well. But we will use the periodic table pretty much every class for the rest of the semester. All right, so let's talk about what's coming up next, just a few reminders. The first one is, so today is the 16th. So first thing, just to remind you guys, we have our first exam on Thursday. So that's exam 1. It's gonna be this Thursday. And it will be done in class. So remember, it's not like the quiz. You won't have until Sunday to finish. You have to come take it in class. You do not have to stay on Zoom video with me the whole time. I suggest that you do, just in case you have questions, and I can easily answer your questions, but we will take it at a specific time. I'm thinking if class starts around 1, maybe like 1:30, we start the exam around 1:30 p.m., just so you guys can ask some last minute questions. So just remember, it will be this Thursday in class. That's the specific time. The second thing is, remember we have chapter 4 homework due this Thursday right before class. And remember that is at 11:59 a.m. So it's due right before this class. You guys, I would just go check it out. It's not a tough homework. It's just so you remember what we're doing in class. And yeah, that's about it for what's coming up. We won't have another lab probably until next week. So we don't have any labs this week. I think we'll have one next week. And if it's not next week, it's the week after. All right, so I just want to recap what we talked about yesterday. So remember yesterday we talked about the periodic table and the elements on the periodic table, and we categorized them and broke them into groups. The main thing that we talked about, remember I had this periodic table, and if you look in the front cover of your book, it's color coordinated for you, but basically you have to know that the metals are on the left side of the periodic table. The non-metals are over here on the right side, including hydrogen. Hydrogen should be over here next to helium, but it has a lot of properties similar as group 1. And so right here in the middle from 3 to 12, we call these the transition metals. And then the groups outside of this, we call those the main group elements. So groups 1 and 2, and then boron, all the way over, we call those the main group elements. And although they say group 1, 2, and then it skips to 13, 14, 15, 16, 17, 18, when I say group 5, I am talking about main group elements, group 5, this column. When I say group 4, I'm saying group 14, group 3 is group 13, group 6 is group 16, group 7, 17, and group 8 is 18. Then we talked about the group names. So the first column, we called them the alkali metals. And we said that they were highly reactive metals. They like to, when they go through chemical reactions or chemical changes, they end up giving away one electron, and that's how they're left with a 1+ positive. And so when they give away that one electron, they turn into an ion and they're no longer atoms. So there can be a lithium atom that has no charge on it, but then when it reacts with other elements, it becomes a lithium ion with a 1+ charge. Same thing with sodium, with potassium, rubidium, cesium. They all will form into 1+ ions. Same thing with group 2 elements. When they react with other molecules and atoms, they like to give away 2 electrons, and that's why they have a 2 positive. It's like they're missing 2 electrons, so it's 2 holes that they would have. And so it would say Be 2+, Mg 2+, Ca 2+. And the transition metals, they also form ions, but because they can form multiple different types of ions, we don't categorize them as titanium having a certain amount of charge. It can form an ion with a 2+, a 4+. Chromium can form an ion with a 2+, a 3+. So it changes. If you're in group 1 or group 2, you only form ions with the 1+, you only form ions with the 2+. So that's why we mainly talk about the main group elements. We skip over the transition metals. And then when we get to aluminum, aluminum is a metal that forms a 3+ ion. So basically, metals in general like to lose electrons when they go through interactions. So all metals are going to have positive charges when they go through chemical reactions. Now, on the other hand, when you get to the non-metals, remember the whole point of this is everyone wants to be stable, like the noble gases. And the noble gases, we'll get to this a little bit later, have a certain amount of electrons in their outermost shell. And that's all that these other elements are trying to do. They're trying to get to the same amount of electrons as the noble gases. So what they end up doing is they either give away electrons or they gain electrons. So the non-metals, they're going to gain electrons. If they're in this column, they're going to gain 1 electron. If they're in the oxygen column, they're going to gain 2 electrons. If they're in the nitrogen column, they're going to gain 3 electrons. And carbon, I said, it can either gain 4 or lose 4, depending on what it's reacting with. All right, so does anyone have any questions from yesterday? Okay, so let's see if we can remember what everything stands for on the periodic table. I'm just going to quickly refresh you guys. When we look at the periodic table and we look in the box on the periodic table.
Professor, I have one question.
Yep. I'm listening. Go on.
On group 14, if we talk about the lead, so it has like 4 ions, 4 positive ions or not?
So you're saying with lead, like 10, and they can have multiple different ions. They're part of this transition metal group. So they can have multiple different ions, so they don't follow. You can have a lead 4, but you can also have like a lead 2. So I'm mainly talking about just carbon.
Oh, that's okay.
Okay.
Thank you.
All right, so if we're looking at the periodic table and I pick an element, let's just pick oxygen, for example. O for oxygen. So at the top of oxygen, there's a number 8. Do you guys remember what that number 8, what that number is called?
The atomic number?
Atomic number, yeah.
So remember, this is the atomic number characterized by the letter Z, in case you see it. The atomic number gives us what, guys?
To the number of protons?
Number of protons. The atomic number never changes.
Does it also show the number of neutrons too?
Not the atomic number. The atomic number, it can also tell you the number of electrons as well, if you're talking about a neutral atom, or if you're just talking about an atom. So I don't like to write out that this is also the number of electrons because it can change. The number of electrons can change. But essentially, remember the protons are a positive charge. And to balance out that positive charge in your nucleus, you want the same number of electrons that are negatively charged so that your overall charge on your atom is 0. So if I have 8 protons, oxygen also wants to have 8 electrons so that its overall charge could be 0. All right, so then this O, we say that's the chemical symbol. And then if we look at oxygen at the bottom of it, it says 15.999. We call this the average
Atomic mass.
atomic mass, or some tables just might say atomic mass. The average atomic mass, remember, it's similar to the mass number, but the only difference is one is averaging the isotopes, and the other one is just saying in this specific isotope, I have the mass of it is whatever. So for instance, oxygen can have an isotope. It has oxygen 15, it can have oxygen 16. In oxygen 15, remember how many protons does it have?
8.
Right, they both have 8 protons. The only difference is oxygen 15 has how many neutrons?
7.
7.
7 neutrons, and oxygen 16 has 8.
8 neutrons, yeah.
8.
Right, so these two are isotopes of oxygen. All right, so remember, so these are isotopes. You can also have ions of oxygen. An ion of oxygen, does anyone know what it would look like? Can you guys tell me what the charge on an ion of oxygen would look like?
Like there will be 2 plus something.
Not 2
And
plus,
O.
but 2
Minus? No.
2 minus.
Okay.
So it would say oxygen 2 minus, and I know it's 2 minus because if I look at the periodic table, oxygen is in group 6 or 16, and all the elements, oxygen, sulfur, selenium, they like to form ions with a 2 minus charge, meaning that they have 2 extra electrons, meaning because they're 2 columns away from the noble gases, so they want to have 2 more electrons like the noble gases. So for instance, if oxygen's trying to be like neon, it just needs 2 more electrons, like neon has 2 more electrons. Or if sulfur is trying to be like argon, it needs 2 more electrons to be like argon. So in this case, the way we'd write an ion of oxygen, it's in group 6. It has a 2 minus charge. It just says O2 minus, which means how many protons does this oxygen have?
8.
8.
It has 8 protons. 8 protons, and how many electrons now does it have?
10.
10.
10 electrons. So this is an ion. That's an oxygen ion. All right, let's pull up this protons, neutrons, and electrons worksheet. I have it printed out. All right, so this protons, neutron, and electron worksheet, this is kind of like the table that's, well, I take that back. I'm gonna have questions similar to this on the test, and you have some on the homework as well, where you'll have to write out what's the atomic number, what's the number of protons, neutrons, electrons, what's the mass number, and what's the charge. So you're always gonna need a periodic table to answer these questions. You just can't do it without one. So let's go through this together. Can everyone see my worksheet or pull it up themselves?
I printed out already.
Okay. Yes, Eve, it would be. All right, so let's go through the first couple together. So this first element is, hold on, let me fix my screen. All right, this first element is PB, which is actually just lead. And so we'd go on the periodic table, we'd look for lead, and lead is number 82. It's all the way down here in group 4 on the periodic table. And the first blank says, what's the atomic number? So we'd go and look at lead, and we'd see, what's the atomic number, guys?
82.
82.
All right, 82. We all get that. Which also means that there are 82 protons. So these two columns should match each other. Now, the next question says, what's the number of neutrons, electrons, and the mass number? Now, to figure out the number of neutrons, I need to know the mass number, or vice versa. To figure out the mass number, I need to know the neutrons and the protons. But remember when I said, if they don't give you the mass number in this case, like if they don't give you the neutrons and the mass number, what you can do is you look at lead and then you round it to the nearest whole number. You round its average mass to the nearest whole number. So if I look at lead, I see that it says 207.2. I need to just round that to 207. This is only if they don't give you both the mass number and the neutrons. So I can say the mass number here is 207. And if I know the mass number is 207, you guys have any idea how to figure out the number of neutrons?
Subtract
Two.
82 from 207.
Right, you subtract 82 from 207, so let's do that. Remember, the mass number tells us the protons plus the neutrons. So you subtract those two numbers, so what's 207 minus 82?
125.
125?
80.
Yes. No?
125. And then to figure out the number of electrons, remember, if we're talking about just lead on its own, the electrons is usually going to be the same number as the protons. So you would think it's 82, but then if you look in this column here, it tells us that the charge on this is going to be +2. So if the charge is +2, that means we're missing 2 electrons or we gain 2 electrons.
We're missing.
We're missing 2 electrons, so we can say that we have 80 electrons. So this is saying that overall, this is really PB2+. All right. Okay. Let's do the next one together. So if we do the second column, I mean the second row, we look at the number of protons. The number of protons says 34. If I know the number of protons, that means I can go and look at number 34 on the periodic table. What's number 34, guys?
Selenium.
Selenium, which is
Selenium.
Yep, selenium. So that means it also has 34 as the atomic number. And now to figure out the number of neutrons, it tells me the mass number. All right, so it tells me the mass number. My mass number says 79. So what do you guys think the number of neutrons is?
45.
45. Where am I? Okay. All right, and then what about the number of electrons?
34.
34. All right, so let's see if we can fill out this pretty quickly up until phosphorus. We're gonna go up until this row. And I'll give you guys a few minutes and let me know if you have any questions. It doesn't matter. Okay, guys. Were we able to get through phosphorus? All right, let's talk this out. So for right here, what element do you guys think number 24 is?
Chromium.
Chromium, so that's Cr. And so that means it has 24 protons. And how many neutrons, guys?
28.
28. How did we get 28 neutrons?
Subtract the neutrons from the mass.
Right, okay, so our mass number was what?
52.
50. So this is one of the cases, they didn't give you the neutrons or the mass number. So we went to the periodic table and just rounded up. In this case, it says it has 21 electrons. So how many, what's the charge? What do you guys think the charge should be?
Positive 3.
It should be +3.
Yes.
3 plus, basically it's missing 3 electrons, 24 to 21. So I'm gonna say it's +3. All right, what about here? What element is this?
It is F, fluorine.
Okay, I see, fluorine, thanks Eve. We know it's fluorine because they gave us a number of electrons and then they said the charge was 0. So since the charge is 0, that means the electrons and the protons are gonna equal each other. So I'm gonna say 9 for the atomic number, 9 for the protons. And then when we get to the mass number, guys, what's the mass number?
19.
19. Perfect, all right. And then if we look at the next one, what element is number 41?
Nobelium, Nb.
We're saying Nb, okay, great. That's also 41 protons. It gives us the mass number, which is 93. So 93 minus 41 is what, guys?
2.
52.
52, all right, perfect. And then we can say the charge, we have electrons is 35. What's the charge gonna be?
+5.
+5, you sure?
Yes.
So we gotta do 41 minus 35. That's gonna give us +6.
Oh, 6.
Now Nb is a transition metal, so you see how the charge can be lots of different things. +6, I think it has a lot of different isotopes. So this is just one of the isotopes. It's not in the main group elements, meaning when we look here, it's here in the transition metals, and it says 5 above it. So we can't, guess or speculate what the ion it's going to form. It can form multiple ions. We only know the ions that are going to form from the main group elements. So group 1, group 2, everything basically in orange. We only know the ions that are going to form from there. All right.
I have one question, Professor.
Uh-huh.
So to find out the charge, we have to subtract atomic number minus number of electrons.
Yep, and so basically if the electrons are lower, it's going to be a positive sign. If the electrons are higher, it's going to be a negative sign. And then I say go through phosphorus. So if we do this, this is 15. And then if we say this -3 is the charge on phosphorus, which it should be because phosphorus is in group 5 and it forms a 3- charge when it turns into an ion. That means it has 18 electrons. And the mass number for phosphorus would be 31. So then we say 31 minus 15 is what, 16? Looks like this.
When we answer them, like in your questions you give, you want the rounded mass number, not the actual one.
So yeah, so there's a difference. I'm trying to stress it to you guys. The mass number and the average mass are different than just, they're not the exact same number. If I'm asking for the mass number, it's either going to be given to you in the symbol on the question, or you need to round the atomic mass to a whole number. All right. Do I have any other questions on this? Because I'm going to go into the atomic mass. All right. In this case, if I keep going, I now want to talk about, let's go back to the atomic mass. Remember, the atomic mass is the average mass of isotopes. It is based off the natural abundance of each isotope. So the natural abundance is just telling us the percentage of each isotope.
So, like even if counting atomic mass, we need to take care about the Sig Figs or no?
Yeah, we do. I will talk to you about that in a second. All right, so natural abundance is the percentage of each isotope. So you would think that if there's two isotopes, let's say, well, there's three isotopes of carbon, carbon 13, 14, carbon 12, 13, 14. You would think that there was about 33% of each of those carbons in the universe, but in reality, there's more of carbon 12 than there is of carbon 13, than there is of carbon 14. And we have to take those percentages into account. So for example, if I'm talking about gallium, gallium has two isotopes. You have gallium 69 and you have gallium 71. These are the two isotopes of gallium. And if we look on the periodic table for gallium, it's number 31 on the periodic table. So all this means, if gallium's number 31 on the periodic table, let's look. Let me show you. Gallium's right here on the periodic table. And you see that its average atomic mass is 69.723. So these are the two isotopes of gallium. It's basically saying in this isotope, I have 31 protons, and then I say 69 minus 31. That means I have what? 38 neutrons. And in this gallium, I still have 31 protons because it wouldn't be gallium if I didn't. But now I have 40 neutrons. In all of the universe, if I was able to go grab a handful of galliums in all of the universe, that would equal up to gallium 69 being 60.11% of all of the galliums. And then the other 39.89% would be gallium 71. So it's not like there's an equal amount of both of the galliums. One of them's more abundant. And that's what I mean by the natural abundance. One of them's more abundant than the other. There's more gallium 69s in our universe than there are gallium 71s.
How do you get that 60%? I know how you get to 39, but
It's given to you, and I'll show you on the interactive periodic table how you can look this stuff up too. But you can just Google it. But in the question, like say we're having to calculate these numbers are always going to be given to you. So what this means is this gallium 69, there's 60% of it. Gallium 71, there's 39, almost 40% of it. Gallium 69, it's called gallium 69 because its mass is actually 68.925 AMU. Remember, AMU stands for atomic mass units. And when you rounded it up to 69, so we call it gallium 69. But the actual mass of the gallium is 68.925.
where are you getting the mass from?
It's given to you, not from the periodic table. This is like given, I know this from questions, it's in the book.
Okay.
Gallium 71, its actual mass is 70.9247 AMU. And when you round it up, it rounds up to gallium 71. So I'm just trying to show you why it's called gallium 69 and gallium 71. So to calculate,
I'm sorry. So each one has a different atomic mass, right?
right,
Not always
right.
going to be the same one. Okay, that's what I'm saying. It's given to you.
Yeah, it's given to you.
Okay.
And let's just take a second and let me pull up the interactive periodic table, just so you guys can see here. Let me pull it up and then I'll share my screen. So remember under contents, I posted the interactive periodic table for you guys. I'm gonna share my screen. Give me 1 second once I pull it up. All right, so share screen. This is the one I wanna share, all right. All right, you guys can see my screen? All right, perfect. All right, so I just clicked on, we go to contents, and then I clicked on periodic table, and then I clicked on interactive periodic table. Here, it gives us the periodic table. It gives us everything we need to know. If I go click on isotopes, this isotopes tab, right, did it open up? Let's see, if I go to gallium. All right, when I clicked on isotopes and then I clicked on gallium, it gives me the isotopes of gallium. I have gallium 71, and it tells me the mass right down here of it. Can you guys see this okay? And then I have gallium 69, and it tells me the mass of gallium 69. I can click on lots of different elements. Let's say I click on chromium. You see chromium has 1, 2, 3, 4, 5 isotopes. Chromium has a lot of isotopes. There's chromium 54, 53, 52, 51, 50. And it tells you each time I hover over one of them, it tells you what the mass of that isotope is right here. It tells you what the abundance is. So for instance, chromium 50, there's only 4% of all the chromiums in the world that are chromium 50. Majority of the chromiums look like they're gonna be chromium, Chromium 52. Because majorities of the chromiums are chromium 52, if you look at the actual mass of chromium, it's actually 51.996, and that's because majority of the chromiums are chromium 52. So its actual average atomic mass is closer to the mass of chromium 52. Does that make sense to you guys? Thumbs up, yay, nay?
Yes. Yeah.
So
I think it's just
when
getting used to the hang of it.
Okay, so when you don't actually have to come find this information, it's going to be given to you in the problem. So like if we just look at our regular periodic table, they're not going to give you all the different isotopes. They're giving you the average mass of all the isotopes. The questions that you're going to be asked is, how do you calculate this average mass given the information of the natural abundance and giving the isotopes? And that's what I'm about to show you right now. So remember, we're on gallium, and it gave us the mass of each gallium, the percent abundance of each gallium, and I'm about to show you how to calculate the actual average atomic mass. So let me stop sharing. All right, so from this information, the way we calculate the average atomic mass, where'd my other pen go? I can say that the atomic mass is equal to the mass, or the fraction, I'll say the mass of isotope 1 times the fraction of isotope 1 plus the mass of isotope 2 times the fraction of isotope 2. And if it has more isotopes, you continue to do that for however many isotopes we have. So let's say we had 3 isotopes. We'd still go the mass of isotope 3 times the fraction of isotope 3, and etc., depending on how many isotopes you have. So if I had 5 isotopes, I'd have 5 different parentheses multiplying the mass of each isotope times the fraction of the isotope. When I talk about the fraction of the isotope, all I'm saying is I'm taking my percentage and I'm changing it into a fraction. So do you guys remember how to change percentages into a fraction?
Divided by 100.
Just divide it by 100. Perfect. Thanks, Pawan. So fractions, I'll just write this here, is just equal to your percentage divided by 100. And remember, your percentages should all add up to what, guys?
The average mass?
Well,
Mass isotope.
when you add up any percentages, what should they add up to?
Oh,
100.
100%, that's all I'm saying. Thanks, guys. So when you add these two numbers together, it should equal 100%. If you're missing a percentage in one of your questions, just subtract all the ones you have to get the last percentage, because we know it's going to add up to 100%. But let's figure out the average atomic mass for gallium, these isotopes of gallium. So if I follow this equation, I can say that I'm going back to gallium here. The atomic mass of gallium should be equal to the mass of isotope 1. So the first isotope, it doesn't matter what you pick as the first isotope, but the first one we see is gallium-69. So I'm going to say that's the mass of it is 68.925 AMU times the fraction of the first isotope. So if I divide this number by 100, what do I get, guys?
68.
But remember, when we're dividing by 100, all we got to do is move our decimal place over 2 spaces. So,
68925.
well, no, that's the mass of the first isotope. I want the fraction So the fraction, you just told me that I just take my percentage and divide it by 100. So the fraction in this case is just gonna be 6.6011.
Okay. Wait, 1, 2.
Yep, we're just moving our decimal place over 1, 2 when we divide by 100.
Okay, yeah.
And if you put it in your calculator, you'll see that too.
Divide by 100, move decimal. 2 places.
Try it and see what you get. All right, so then the next one, I'm now doing the mass of isotope 2. The mass of isotope 2 is this number right here. So that's going to be 70.9247 AMU. And this is times the fraction of the second isotope. What's the fraction of the second isotope, guys?
39.
3989.
3989.
0.3989, perfect. All right, so when we talk this through and we talk it through as it relates to significant figures, what we're saying is we still have to follow the multiplication division rules as well as the adding subtraction. So these parentheses say multiplication, but then I have an addition rule in here as well. So, you know, we're gonna follow the order of operations, which says I'm gonna do my parentheses first. So when I put this in my calculator, I'm just looking at this part. You guys, what's the rule say for multiplication in Sig Figs?
Least common.
The least amount of Sig Figs?
Yep, least amount of Sig Figs. So what's the least amount of Sig Figs of these two numbers?
4.
4.
4.
So this answer should have 4 Sig Figs in it. So I'm gonna go ahead and say 68.925 times 0.6011. And if I put this in with 4 Sig Figs, technically it should be what, 41.43? But remember, we're still not gonna round into the end. So I'm just gonna write the other numbers in orange so you guys know that I'm not really taking them into account. That should be enough.
We don't need to add additional like 7.5. There is a up to 7.5.
You can put that in there, but that's probably enough Sig Figs. I mean, that's probably enough numbers for right now. So, all right, so then let's do the next one. If we look at our next parentheses, how many Sig Figs should we have in this answer?
4.
4 again. This is just a multiplication rule. We're gonna get 4 again. So let's multiply these two numbers together, 70.9247 times 0.3989. I end up getting 28.29. Those are my 4 Sig Figs, so 28.29. And then I'm gonna write the other one in orange, which is the 186 or so. 186. So now we are adding these two numbers together. When we add these two numbers together, what's the rule for Sig Figs?
Least decimal place.
Least decimal place. What's the least amount of decimal places?
2.
2. Yep. Because remember, I stopped. These are right here. This is 2. This is where the numbers technically stop it. The orange numbers are just showing me I'm not rounding into the end. So I'm going to add those two numbers together. 41.43081. And I end up getting, with 2 decimal places, I end up getting 69.72. Did you guys get that?
Yes.
And if we look at our periodic table at gallium, it says that the average atomic mass is 69.723. That's how we get this number. And if I wrote out another, if I rounded it to the next sig fig, I would say 0.723 as well. You guys got the same answer. So that's how we figure out the average atomic mass. So let me do an example where you guys have to figure it out and see if we guys get the same answer. Let's see if I can find an example. Let me look in the book. This is chapter 4. All right, I'm pulling one straight from the book. Do I have any questions before I keep going? All right, so this is what the questions would look like. It says rubidium has 2 naturally occurring isotopes. There's rubidium 85 with a mass of 84.9118 AMU and a natural abundance of 72.17%. And then there's rubidium 87 with a mass of 86.9092 AMU and a natural abundance of 27.83%. The question says, let's calculate the atomic mass of rubidium. Okay. Here, it's right here. All right, so this is the question. We have 2 isotopes, rubidium 85, rubidium 87. Let's use the equation to calculate the atomic mass of rubidium. Hmm? Okay, good. I think you should write it down. All right, let me know if you guys have any questions. And give me a thumbs up if you guys feel good about this.
Mine came like 85.47.
Okay, let's talk it out. And the only issue you guys have with this is that you forget how to do it, especially at the end of the semester when we have the final. And you guys, well, the question will say, calculate the average atomic mass, and you guys will just take the masses and divide it by 2. That's not how we're gonna do that. We gotta actually take into account the percent abundance. That's the important part. So put a star. It's not anything difficult to do, but it's just remembering that it's not like the regular average. All right, so if I go through the steps, we're gonna say the first isotope is 84.9118 AMU times the percent abundant. What's the fraction for the first isotope?
0.7217.
7217. All right.
And really quick, just to clarify, those natural abundance percentage will be given to us in.
The only time it's not given to you is, let's say it gave me one of them and I had to figure out the other one. You guys just have to remember it's supposed to add up to 100%. So you just subtract it from 100 to get the other one. All right, so then the next one says it's 86.9092 times the fraction. What's the fraction, guys?
0.2783.
So this should say AMU times 0.2723. Both of these need 4 Sig Figs. Most likely those 4 Sig Figs are going to give you 2 decimal places. So did you guys get 2 decimal places in your final answer?
Right, we got it.
All right,
Yeah.
so what's the final answer?
85.49.
85.49.
85.47.
85.47.
85.47. It should be 47 because when I look at the periodic table, it says 468. So if I rounded it up, it should say 47. So you can always double check yourself by looking at the periodic table. Just know on a quiz or a test, it's not going to be any of these elements. It's going to be an element that I've made up, like leonium, which is my name with an IUM at the end of it.
It is the 61.28 plus 24.18.
61.28 is what you said, plus 64.28?
61.28 plus 24.18.
Okay. I believe you guys did it correctly. So this should be AMU, which brings me to the point. Usually, guys, it's not every time, but usually when we're calculating the average atomic mass, it is going to be the 2 decimal places, but you still need to follow the Sig Fig rules and get it. And then you'll see that when we go to round our average atomic masses, when we're going to add them up later, we're going to always round the 2 decimal places. But I'll get to that. That's the next chapter. Let's take a quick break if I don't have any questions. What's that noise? All right, you guys want to take a quick break? Let's make it quick because I don't have that much more to talk about. I just want to go over some more examples. And so maybe like make it like 5 minutes. Is that enough time or do you guys need 10 minutes? If we need 10, that's fine. I just don't want to make it 15.
I wouldn't mind 10.
Okay, let's do 10. And then I don't have that much left. I just want to go over some more example problems so it's clear how we work out the even tougher ones. So I'll take a 10-minute break and come back. I'm gonna go find something to snack on. I'll post this later.
All right.
I was trying not to record the breaks so it wouldn't be like 10 minutes of silence and then I always forget.
Okay.
All right, so then we're saying copper 65, when we get to the second isotope, we don't know what its mass is, so we're gonna say X, and then we're saying that times the fraction, 0.391. And we say it's all equal to this number. So we have to set it up and solve for this X. So meaning you just multiply these numbers together, get an answer, multiply this number together times X, and it's all equal to this. So it's like saying 10 plus 5X equals 20. Who was trying to open my door? Okay, so have we got through number 3? All right, so if we set this up, this is what the equation looks like. So if I multiply these two numbers together, I should have 4 Sig Figs. What's this? So it's going to be 62.9298 times 0.6909. 4 Sig Figs gives me 43.47. And then I'm going to write the other ones in orange so I know that I'm just not rounding into the end. 819. And then I'm saying plus basically 0.091x. And all this is equal to 63.546. Now, if you're having trouble solving for unknowns, you just might need to reach out to me and we can do a little practice. But basically, I do expect you guys to know how to set up an equation like this and solve for your unknown variable, which is X in this case. So remember, the whole point is we got to get the like terms on both sides. So basically, we get the X on one side, and if it doesn't have an X, you get it on the other side. And the easiest way to do that is subtract this number from both sides. What is this, 43? All right, when I subtract them from both sides, those two numbers cancel out. And I end up getting 63. I end up getting 20.06. So remember, this had 2 decimal places. When I subtracted it from both sides, this has 3 decimal places. So this answer still needs 2 decimal places. But once again, I'm not rounding it to the end. So this is 20.0678. And then this should be equal to 0.3091x. And if I solve for x, that means I need to do the opposite of what's happening to x, which is being multiplied. So I need to divide both sides by 0.3091. Divide this side by 0.3091. And I end up getting 4 sig figs divided by 4 sig figs, 0.3091. I end up getting 64.92. Did you guys get that?
Yep.
Okay, so x equals 64.92. And remember, all x was the mass of copper 65. So this equals the mass of copper 65. It should be an AMU. And that's what the question is asking. So does this make sense to you guys? Or let me know if you guys have any questions. Okay. So if it makes sense, I see a lot of thumbs up. Okay, good. If it makes sense, let's just do number 5. Let's see if we can figure out number 5, and then we can end class at this. Number 4 is the exact same way as number 3. I'll leave that for you to practice on your own. But number 5, I just want to make sure we can figure out how to figure out what's missing. So number 5 looks like this. It's a table. It tells us the percent abundance. We're missing 2 blanks. If we have 2 blanks missing, let's see if you guys can figure out how to find the missing percent abundance, and then how to find the missing isotopes mass. You should look at the periodic table to figure out the average atomic mass. Mhm.
We're doing number 5, right?
Yep, number 5. Okay, how's it going for number 5? You guys stuck or is it making sense?
I'm stuck.
Stuck? Okay.
Mhm.
Does anyone know where to start off the first step?
I mean, you would just look up the average mass, right? So
Okay,
it
yeah.
could be your number.
Yep, so we can do that. That's a good first step, the average mass. So what did you guys look it up and see?
20.180.
Yep, that works out. So you can look at that from the periodic table, 20.180. All right, so that's a good first step. What about a next step?
Is it cheating if you checked on the interactive thing
Yeah,
for
so
the relative
You will.
percentage?
I hear someone talking. I see you wrote it in here, Eve. Someone else say it? Can someone say it out loud about the relative percent?
0.27.
Okay, so we know that this total should be 100%. So the missing percent is gonna be 0.27%. And the way we got that is we just said 100 minus 90 minus 9.22. So did we all make it this far? Or do we see it
Yes.
now, please? So if we got this far, now all we're trying to do is say, this is my X. And we're gonna set up an equation just like we did for number 3. So meaning, we gotta say our mass times the fraction, plus this mass times this fraction, plus this mass times this fraction should equal 20.180. And I'll write it out for you. So let me grab my book so I can be a little higher.
I'm not clear about how the 20.180 came.
That's from the periodic table. We just had to look at the periodic table to find that number. So we just went to Neon, look on the periodic table, 20.180.
It looks like for whatever reason, my worksheet is missing some decimals. I don't know how close I can hold that up, but it's only goes to the 10th place for this particular chart. So I might get a different answer.
Yeah, okay. Does anyone else's look like mine?
No.
Yes or no? Oh, okay. Well, guys, sorry. I don't know what happened. Maybe I uploaded a different version. So you guys, mine looks different, only to the 10th place. Okay, you guys just write out these other decimals then into yours. So like the 19.992, 20.994. What about for the relative abundance?
For the same reason I got 0.28 instead of 0.27.
Okay, got you. Well, write it out like mine, because this is the one I'm gonna post later. And it doesn't really matter. You still go about it solving it the same way. So it's no big deal, actually. Let's just set it up. So if I set it up, here, let me set it up right underneath, which says 20.180 equals 19.992 times, what's the fraction here? The 0.9051 plus 20.994 times, let's put this in fraction. What is this as a fraction, guys?
0.0027.
0.0027. This is a common mistake you guys make too. Just remember, you got to go over 2 decimal places or divide by 100. So a lot of times when you have a number that's like less than 10, you guys only do 0.027. All right, so don't make that mistake. And then finally, we're saying X times, what's this as a fraction?
.0922.
Right, 0.0922, and I'm gonna say times X, because that's how I wanna write it. All right, when I add all these numbers up, I'm gonna do it in one step. So it's just like number 3, you get a number for this parentheses, you get a number for this parentheses, plus 0.0922x. You can add these two numbers together and then subtract them from 20.180. So I'm gonna do it all in one motion. So I'm gonna say, what's this? Open parentheses, 19.992 times 0.9051, close parentheses, plus open parentheses, 20.994 times 0.0027, close parentheses. So I'm going to get an answer for those two numbers. These two numbers, I'm assuming, needed two decimal places. And then I'm going to subtract this number, this 20.180, from the answer. And I ended up getting 2.02857 equals 0.0922x. And then I'm going to divide both sides by this 0.0922x, or 0.0922. And I ended up getting 22.00. So my X, and if you got something different, that's probably because we had different numbers, guys. But neon 22 should be 22.00 or somewhere close to it, because that's how we get neon 22. And I'm going to say this is for neon 22. So this is AMU. This is my answer. Remember, this is the answer to that.
So would we, as we're doing, if we were to, for instance, take the two parenthesis blocks that you have and multiply them separately, would we apply the Sig Fig rules before adding them together?
Yes, I should have done that. I didn't want to write it all out. So this is 4 Sig Figs, which will probably be 2 decimal places. The second one is going to be 2 Sig Figs, which is probably still 2 decimal places, but let me just see to double check. Yeah, well, 2 Sig Figs in this case was 3 decimal places.
Okay.
So, you know, when we add it all up, the least amount of decimal places is still just going to be 2 decimal places.
Yeah.
So 2 decimal places when you add these two up, and then when you subtract, it's still going to be 2 decimal places. So this number should be 2 decimal places. And then you say 3 Sig Figs divided by 3 Sig Figs, or 3 Sig Figs divided by 3 Sig Figs. This should actually be 22.0. So let me just write it correctly so there's no issue with 3 Sig Figs. Okay, does this make sense to you guys? Can I get a thumbs up or a yes?
Yes, it does.
So this is pretty much everything that's going to be on the test on Thursday. So this is the end of chapter 4. Right? Is this the end of chapter 4? Yeah. So this is pretty much everything that's going to be on the test. I do have a exam review, just like about 15, 20 questions that I can post tonight, and we can go over the answers tomorrow. I just kind of want to do a review tomorrow, basically, including the labs, going over the most common missed questions from the labs. And yeah, so tomorrow it's just gonna be a review day, and then Thursday we're gonna go ahead and take our lab, and then you don't have any homework over the weekend. And so just remember that our homework for chapter 4 is due Thursday morning. So guys, if you haven't started, go ahead and get started. I've covered everything for chapter 4. It's not a tough set. A lot of the questions are just multiple choice. Remember, you have 2 attempts. I think I got an email, I can't remember who it was from, saying that they needed help figuring out what they're doing wrong with their homework. I need to know specific questions. Guys, if you're emailing me, I can write you back right away. If you give me the specific question, like, I don't understand why I got this problem wrong. This is what the problem says. I'm usually on my cell phone when I'm emailing you back. And if I have to wait till I get home to go look up the questions, it just takes much longer. So if I don't have any other questions, guys, that's it for today. And remember, like I said, go get the homework done. And I will post all this information, hopefully within the next couple of hours. And if you guys don't see it by like 7 o'clock, send me a quick email and I can just go run and do it really quickly.
And all the questions that are going to be on the review are going to be on the final, I'm sorry,
The
on the
exam.
test, right?
Yeah, so
For
pretty
this
much
Thursday?
everything I've covered is going to be on the exam. I just give you just review questions just to remind you, like, oh, we did talk about this, this, and that.
Okay, sounds good.
Okay. And
Thank you.
no problem. Feel free to email me, guys, if you have any questions.
Okay, bye.
All right, bye.
Thank you. Have a great day.
No problem. Bye. What'd you say?